Good afternoon from Hanover and welcome to the 5G ACI demonstration session. I am Afif Serran, the General Vice Chair of the 5G ACI Alliance. I work with Ericsson. I'm based in Stockholm. I'm Director of Industry Engagement and Research. You will hear in this session from our members about their experience in industrial 5G. First, Lisa from IFAC in Germany will show us how performance testing for industrial 5G is done in a lab. Then Johannes from Viavi will tell us more about the importance of system integration in a 5G non-public network. Then we will listen to Weidmuller, an OT player, how they are engaged in industrial 5G and the use cases they focus on, in particular real-time communications. Finally, we will hear from Bicel about the end-to-end solutions for a cellular network in a factory. So now, let's go live to the IFAC Institute in Magdeburg and hear more from Lisa in their bear about performance testing.
Welcome everybody, thanks for joining me today. My name is Lisa Underberg and I'm with the Institute for Automation and Communication based in Magdeburg, Germany. And at IFAC, industrial automation is in the center of our attention. So we're focusing on the applications point of view. This is why we developed an approach to stress test the communication network from the applications point of view. Currently I'm standing in front of the building, the Galileo test site Saxony-Anhalt, where we typically conduct our performance testing. So let's go and take a look inside. As an industrial environment is often challenging to wireless communication networks, we're using this test site as a reference environment emulating a real-world industrial facility. During performance testing a wireless network, we carefully create reproducible conditions. By this, we ensure that the testing results of different technologies, devices or even prototype versions are comparable. For the emulation of movement of a certain speed, we're using a motion measurement station. While the performance parameters are observed, the devices moved along the station's trajectory. Wireless devices are usually connected to an industrial application or integrated into one, for example a PLC and its devices. In order to analyze the communication network's performance from the application's point of view, we connect these wireless devices then to our measurement equipment. The multiphases emulate an industrial application. For example, the communications transfer interval is reproducible with an accuracy of less than 1 microsecond. If we want to create even more stressful conditions, like a distance larger than we have here in our reference environment, we use our laboratory at IFAC. Luckily, it's just a few minutes walk away. In our laboratory, the wireless devices are put into shielded boxes and connected by wire to a channel emulator. The channel emulator attenuates the signal according to a preset. Performance testing from an industrial applications point of view is challenging and yet indispensable when trying to decide whether technology is suitable for a specific application or not. This is also recognized by 5G ACIA, who published a white paper on performance testing of 5G systems in industrial automation in April 2021. And with that, thanks for your time and back to the studio to Afif.
Thank you, Lisa. Lisa, you mentioned the 5G ACIA white paper on performance testing. Can you tell us more about it?
Performance testing from the industrial applications point of view is challenging and yet indispensable when trying to determine whether a communication network is suitable to meet a specific application requirements or not. So the mentioned white paper provides a step-by-step explanation of what to consider when preparing and conducting performance tests. For example, the performance parameters to be measured and the baseline parameters to be described are defined. And from my point of view, I think it's a really worthwhile white paper to spend some time on, as the presented concept of performance testing is a universal one. That means that it can be not only applied to a 5G network, a standalone 5G network, for example, but also to hybrid networks, like a 5G network in combination with a legacy industrial Ethernet network, for example.
Lisa, speaking of hybrid networks, 5G in particular, release 16 will support time-sensitive networking protocol that is expected to be widely used in the coming years in manufacturing. Can you explain A, if there is any relation to the current technologies based on industrial Ethernet networks? And B, can you tell us more about the characteristics of these industrial Ethernet networks?
So industrial Ethernet-based communication networks are current state-of-the-art in industrial application, in industrial automation. They are typically grouped into three classes: Class A for best effort traffic, Class B for real-time traffic, also referred to sometimes as soft real-time traffic, as opposed to Class C, which is aimed at isochronous real-time, also referred to as hard real-time sometimes. In Class B and C, these networks have similar characteristics. They all provide layer 2 communication, so without using IP communication, they work in short communication cycles with cycle times of less than 1 millisecond, for example. They have a high number of very small packets to be transported, which of course correlates with the small cycle time. They all enable a highly precise synchronization, which is crucial for a distributed application to synchronize its distributed clocks to enable a highly complex automation task. They do that typically with a jitter of less than 1 microsecond. So this is a really crucial characteristic that the industrial automation application relies on when using this industrial Ethernet-based network. And last but not least, these networks also support functional safety protocols. In this context, TSN is able to provide layer 2 mechanisms that are compatible with these industrial Ethernet-based communication networks, and this compatibility allows the legacy networks to be extended, for example, by a TSN network. So it is possible to form a hybrid network that suits the application requirements best.
Many thanks. My final question to you. What are the main industrial control application use cases that we expect 5G to support?
So first of all, industrial control applications are a topic that is so diverse that 5G ACIA published an entire white paper on that topic. So just to name some examples of areas where we can find industrial control applications where 5G networks will be deployed successfully are the areas of motion control, control-to-control communication, or control-to-sensor, control-to-actuator communication. There's also motion control, mobile robots, remote access and maintenance, closed-loop process control, process monitoring, and plant asset management. Typically, there are 3 use cases in which a 5G network can be deployed to support these applications. The first use case is the controller-to-controller communication, or also line controller-to-controller communication. Secondly, the device-to-controller communication. And thirdly, the device-to-compute communication. And if you are interested in more information on that topic, please refer to the 5G ACIA white paper on the integration of industrial Ethernet networks with 5G networks.
Thank you, Lisa.
Okay, thanks, Afi.
The second intervention in this session will be done by Johannes from Viavi. Let's hear directly from him about the system integration role in 5G non-public network.
Thank you, Afi, for the introduction. How to avoid buying a pig in a poke, or as we say in German, die Katze im Sack kaufen, when you contract with your favorite system integrator. Your enterprise wants to make use of the advantages of 5G non-public networks, or NPN, which I think is a good choice. When investigating possible options, open radio access networks raise your interest. But how to make sure the different O-RAN components work together smoothly? My name is Johannes Weichsel. I work as a business development manager for EndtoEnd Solutions, and I want to give you some guidance on how to make most of your private 5G network. When it comes to deploying a private network based on O-RAN, system integrators play a prominent role. Your SI will help you make sure a solution built from individual components, from probably a mix of vendors and open source, is tested for interoperability as well as for different use cases. Depending on the delivery model you choose and the tasks you want to do in-house, they will support you in the build, activation, and also the maintenance phase of your network. But even if you trust in the capabilities of your SI, you still want to make sure that everything in your NPN works well today, tomorrow, and for the next 10 years. Therefore, I want to equip you with some questions you might want to address to your system integrator. The list of possible test scenarios is quite long. The system under test, or SUT, can be a single network element or the whole 5G core. When doing load tests, the whole 5G non-private network can be the SUT. In this case, a large number of user equipment devices, or UEs, can be simulated to generate traffic. Depending on the use cases of an enterprise, these different scenarios have to be adapted accordingly. A mining company has different requirements than a logistics company. 3GPP releases new update specifications every year. An ORAN vendor release might come as frequent as several times per month. Some of these 3GPP updates might be essential for future business requirements to be met. Before your productive system on-site is upgraded to the new version of the standards, you definitely want your SI to do proper regression testing. What does their release management look like, and do they have means to perform the tests properly? Is all of this part of the current price and offer you have received? And always keep in mind the regulatory compliance and associated certifications that apply for your sector. You don't want your NPN to become a source of security breaches. How does your SI's security measures look like? How do they make sure that security-relevant bug fixes are applied in a timely manner? Does that seamlessly integrate in your company's security concept? Operational technology networks have commonly been physically isolated. Defining a logical trust domain and at the same time managing third-party access when needed requires to rethink the approach to security in general.
Thank you, Hannes, for insights about the system integrator role in a 5G non-public network. I have a short question to you. What is your ultimate advice for someone that wants to get a private 5G network?
Stability, performance, and long-term support do not come for free. Traditional vendors can probably tell you a lot about that. For your all-round endeavor, make sure to find a partner that you can rely on today, tomorrow, and for the next 10 years.
Thank you. The next discussion will be between Daniel and Dimitri. They are both from Weidmuller. They will tell us more about their experience with industrial 5G, in particular real-time communications. Let's directly go and hear from them.
Hello, welcome to our future talk 5G from Weidmuller. Next to me, it's my dear colleague Daniel Behnke from the Factory IT.
Hello and welcome.
My name is Dimitri Block and I'm from the Technology Development. 5G, almost every day it's in the news. Frequency auctions and also the first 5G ready devices already are on the market. But what is the major potential of 5G? 5G is not only focusing on high data rates. It is focusing on 3 different clusters of use cases. Here it's shown in a triangle. Enhanced mobile broadband, that are the high data rates. Massive machine type communication, the high device density, but also energy efficiency to operate sensors on battery for multiple years, and ultra reliable low latency communication, real-time communication with a reliability of 99.99%. These 3 clusters can be used in multiple ways. But what does it mean especially for the industrial connectivity, for our factories, for our production side, Daniel?
Thank you, Dimitri. So as Weidmuller, we've been looking at 5G technologies now for 3 or 4 years, mainly in research projects. We are working in different research projects from a European level, also from the government of North Rhine-Westphalia. But we are also taking a look at these technologies in our innovation area here at our production site in Detmold, where we want to use 5G components at a very early stage, test them, evaluate them, and see the benefits of 5G technologies. What are the use cases we are looking at? So, for example, we're taking a look at network function virtualization, where we want to see if it's possible and suitable to replace classical hardware network components with software, using them, for example, to gain some more flexibility, developing a protocol converter from Euromap 63 to MQTT as one example. But we are also taking a look at the usage of 5G private campus networks, in comparison to the public infrastructure networks, see the benefits of both solutions for us. I want to show you one use case, which is very interesting for us. Here we have a look at our assembly line for us. And you can see here on the one hand, we are talking about control, so ultra reliable low latency, as you've mentioned before, but also on sensors, energy monitoring. So many fold user equipment, different 5G components, and with very different traffic types. But Dimitri, what's also very interesting for us to know is what is Weidmuller currently working on in the term of 5G components.
Thank you. 5G enables the combination of industrial frequencies for private networks combining with ultra-reliable low-latency communication. And this combination enables for cable replacement, especially targeting real-time communication. And here we see, for example, a concept which advances this concept even into the field, into the IP67 field conditions. So, and therefore we have to focus on different challenges. What is about antennas, exposing antennas, internal antennas? What is about real-time communication itself? Which kind of cycle times do we need? Which kind of communication is required? And the major part is, what is about reliability? Reliability of 99.999% requires long-term evaluation of such kind of concepts and products. This content is also contributed to associations, relevant associations, and we like to see you as a partner, Weidmuller as 5G partner for the supplier side, but also for the operation side. Thank you very much for listening to this talk, and stay healthy.
Thank you.
And now we reach out the final presentation. It will be done by Wei from Bicell. He will tell us more about the 5G end-to-end network solutions in a factory.
Founded in 2014, Bicell's Technologies provides in-house design for RRU, BBU, CPE, and core network. With the characteristics of high throughput, low latency, and architecture flexibility, 5G helps the industrial manufacturers transform to a more intelligent network. We offer complete end-to-end solutions at factories, mining, transportation ports, and emergency communication. Bicell solutions supporting 4G, IoT, Wi-Fi, and 5G technologies. From the material acquisition to assignment, semi-product transporting and storaging, it is controlled by different sensors with real-time data that can monitor from the station and the control room. Monitoring the production process, 3D scenario display. raw material preparation, auto transport to the assigned production line, record all the production specs, the safe production environment is now monitored remotely with our 5G intelligent solution. Automatic handling of products. Intelligent logistics system manages the warehouse and production capability. Safe and reliable network performance. Real-time monitoring. Maintain. Bicell's 5G one-stop solution will provide reliable and efficient solutions for traditional manufacturing, 5G media, oil and mining industries in future. 4G, IoT, Wi-Fi, and 5G technologies most important, we combine the system to one.
Bei, can you tell us more about the 5G solutions for a smart factory?
To answer this question, we need to firstly understand what 5G can bring to us. Bicell's 5G system have three major characteristics. One is big bandwidth, second is low latency, third one is massive access. Big bandwidth can enable high-definition video capturing. Thus, we can recreate the whole image via the augmented reality or virtual reality. Low latency can enable very precious operation from the remote, thus eventually enable the online and offline coordination. Massive access can help us to collect as much as data from all the kinds of devices. Thus, eventually, we could do a lot of big data analysis and processing the data. With the network slicing capabilities, we can resolve all the requirements within one system. Last and the most important thing is Bicell try to build the system as simple as possible so that the factory does not need a telecom expert to operate the system. A normal IT engineer would be good enough to make the factory smart via the Bicell's 5G technologies.
My second question to you is about the value that 5G can bring or brings to the factory.
The value 5G can bring to the industry application would be the flexibility of building a factory and also the visibility of how much we consumed and how much we generated.
And here is my last question to you, Bei. You mentioned the manufacturing sector. Can you tell us more about other sectors that you believe 5G will enable?
We believe 5G is the key technology to enable the high-speed digital path to Industry 4.0 with the capability to rebuild the image from remote. We can enable video entertainment. We can enable also the remote medical care or elderly care. We can also enable oil and gas for security reasons together with the artificial intelligence.
And this was the final presentation in this session. I hope you enjoy it. Please stay with us. The next session will be later on at 5:30 tonight. Thanks for listening.